Welcome to MTech's webinar series. Today's topic is navigating the future of quality assurance within the insurance testing industry. Today, I will introduce myself and the company I work for, the importance of leveraging automation in software testing. I will introduce you to knowledge graphs and how they are revolutionizing automated software testing, particularly in the life insurance value chain. I then will touch upon other automated software testing methods and how software testing is trending.
My name is Spencer Rubin. I have been involved in software quality assurance and testing for the past 25 years. I've worked in many different software environments, and I've watched the evolution of software testing. Today, I'm happy to share with you the benefits of MTech's new exciting product, QMT. Our product, QMT, features full end-to-end testing coverage combined with automated test case and data generation, providing a codeless method into testing business logic and workflow. The model automates the generation of all tests by traversing through the knowledge graph model, which produces all possible permutations of the business logic. These test cases are then executed in an automation framework and the results reported. QMT is user-friendly and can be managed by QA team members or non-developers who understand the business flow.
All software development teams test their products, yet delivered software always has defects. Test engineers strive to catch them before the product is released, but they always creep in and often reappear. Even with the best of manual testing processes, test automation software is the best way to increase the effectiveness and efficiency and coverage of your software testing. Manual software testing is performed by a human sitting in front of a computer, carefully going through the application screens, trying the various usage and input combinations, comparing the results to the expected behavior, and the recording of their observations. Manual tests are repeated often during the development cycles for source code changes and other situations like multiple operating environments and hardware configurations. An automated testing tool is able to play back in pre-recorded and predefined actions, compare the results to expected behavior, and report the success or failure of the manual tests to a test engineer. Once automated tests are created, they can be easily repeated and then be extended to perform tasks impossible to do with manual testing. Because of this, savvy managers have found automated software testing to be an essential component of successful development projects. Automated software testing has long been considered critical for big software development organizations, but it's often to be too expensive or too difficult for smaller companies to implement. So let's talk about some of the benefits of automated testing. Automated testing saves time and money. Software tests have to be repeated often during development cycles to ensure quality. Every time source code is modified, software tests should be repeated. For each release of the software, it may be tested on all supported operating systems and all hardware configurations. Manually repeating these tests is costly and time-consuming. Once created, automated tests can be run over and over again at no additional cost, and they are much faster than manual tests. Automated software testing can reduce the time to run repetitive tests from days to hours, a time savings that translates directly into cost savings. Vastly increases your test coverage. Automated software testing can increase the depth and scope of tests to help improve software quality. Lengthy tests are often avoided during manual testing, can be run unattended. They can be run on multiple computers with different configurations. Automated software testing can look inside an application and see memory contents, data tables, file contents, and internal program states to determine if the product's behaving as expected. Test automation can easily execute thousands of different complex test cases during every test run, providing coverage that is impossible to do during manual testing. Testing improves accuracy. Even the most conscientious tester will make the mistakes during monotonous manual testing. Automated tests perform the same steps precisely every time they are executed and never forget to record the detailed results. Testers freed from repetitive manual tests have more time to create automated software tests and deal with complex features. Automation does what manual testing can't. Even the largest software and QA departments cannot perform a controlled web application test with thousands of users. Automated testing can simulate tens of hundreds of thousands of virtual users interacting with the network software and web applications. Automated testing helps developers and testers. Shared automated tests can be easily used by developers to catch problems quickly before sending to QA. Tests that can be run automatically wherever source code changes are checked in and notify the team or the developer if they fail. Features like these save developers time and increase their confidence. QA and dev team morale improves. This is hard to measure, but we experience it firsthand. Executing repetitive tasks with automated software and testing gives your team time to spend more challenging and rewarding projects. Team members improve their skill sets and confidence, and in turn pass those gains on to the organization. So let's shift our automated testing discussion towards leveraging knowledge graphs. Knowledge graphs help to visually express the relationships between data, information, and business flows. So let's talk about components of a knowledge graph. Knowledge graphs contain three different components: nodes, edges, and labels. For an insurance carrier, a node is a question in EAP while the edge is an answer. An example would be name equals John or age equals 46. During the underwriting process, a node represents an action in a flow of the underwriting system while the edge is a direction. Example would be check status of the policy, or make initial payment, or verify signing process. During the policy administration system, a node represents an action in the flow of the policy administration system. An example would be update beneficial owner, or update address, or update payment method. So what are the key benefits of using knowledge graphs? Well, it eliminates the need to repeatedly find or create or refer to paper documentation of business requirements, logic, and flows across the value chain to establish end-to-end testing. And some of the key outcomes of using knowledge graphs are provide a simple way to use model of all the relationships across business systems. It provides the big picture of the relationships of flow of data between different systems or data silos in a visual. And it eliminates the need to manually design tests which scenarios to cover. Test cases and test data are automatically generated. By using QMT, end users build a knowledge graph, which is a visual model of the business logic, rules, and requirements and goals across the full ecosystem of core and supporting systems. This goes by traversing a graph, automatically generating test cases with test data. It takes the guessing out of test case creation, and it changes to a model or available the next time the test cases are generated. To recap, why would you use knowledge graphs for software testing? Knowledge graphs improve software testing. It enables the testing of all possible scenarios resulting in unmatched coverage. You experience improved defect detection, and very importantly, you reduce customer dissatisfaction and ensuring the reliability and quality of the insurance products. So let's take some time to look at how software testing is trending. AI and machine learning can be applied to software testing to automate various steps in the testing procedure. AI-driven testing solutions can, for instance, assess the application being tested and produce test cases to cover important sections of the application. Software testers can save time and effort by doing this and trust that the most crucial portions of the program are adequately tested. Testing data analysis and trend identification can be both done using machine learning, enabling testers to concentrate on the application's most important features while lowering the number of test cases. Additionally, faults and errors can be automatically detected using machine learning methods. Machine learning becomes especially helpful in large-scale applications where manual flaw detection may be more time-consuming and ineffective. AI-powered tools can enhance the software testing quality by identifying defects and bugs that might otherwise be missed. These tools can analyze large amounts of data and provide insights that improve overall quality of the application under test. Furthermore, AI can help identify patterns and trends in testing that can help improve the testing process and prevent defects from occurring in the future. The data-driven testing methodology involves running a sequence of steps repeatedly against different input values retrieved from the corresponding data source. It is widely used for verifying the inefficiency and behavior automated tests when dealing with a wide range of inputs. The number of tests you run to ensure your code functions appropriately grows along with your software. You can use the same test case using various inputs when using data-driven testing. This increases the coverage of a single test. Data-driven testing enables the opportunity to combine positive and negative test cases into a single test, also enhancing the test coverage. As cloud platforms like Azure and Amazon Web Services become easier to use and add feature sets, test automation engineers and managers, and really anyone in the realm of software testing, must now evaluate the advantage of running their tests on the cloud infrastructure, provisioned on demand and managed over the internet versus using in-house infrastructure resources. So just a few closing remarks. Knowledge graphs provide comprehensive and testing coverage. Automation reduces manual efforts and accelerates QA cycles. Future trends, including AI, machine learning, and cloud-based QA, will continue to transform the industry. MTech's QMT software leverages knowledge graphs and embraces the future of software testing. I hope you enjoyed today's webinar. Please stay tuned for more webinars and communications from MTech. Thank you.